Hi guys! For today's video, I'm going to show you a really cool science experiment magic trick where you can make two balloons that look like they should go apart come together. And then I'm going to explain to you the science of why that works, which is also the same reason that planes can stay in the air. So the first thing that you're going to need is two balloons and two pieces of string. I've made one right here, so you just want to blow up a balloon about this size and then tie about 2 feet of string onto it. Make sure it's pretty tight so that it won't fall off. Then the next thing you're going to do is you're going to take these two balloons and you're going to tape them somewhere where they can hang. So I put mine in a doorway. You can also have somebody hold them as long as they hold them really still. Now I can't do this part of the experiment outside because the wind's going to blow them. So I'm going to explain what to do and then I'm going to show you a clip of me doing it inside my house. But once you hang them up, you're just going to want to very gently blow some air right between the two balloons. Before you do this, ask someone in your family or a friend, what do they think is going to happen? Most people think that the balloons are going to blow apart, and that makes sense. If you blow some air between them, it looks like it should blow them apart. But, as you'll see in this video clip, they actually come together. So how does that work, and what does it have to do with airplanes? Well, it works because of something called Bernoullis Principle, which is a theory that was designed by a scientist named, you guessed it, Bernoulli. His theory has to do with air pressure, so let's talk a bit about what that is. To explain pressure, I'm going to use these two arrows. So, pressure is when you push on something. If you push this way, we're going to use an arrow pointing this way. And if you point this way, we're going to use an arrow pointing this way. So hopefully that's clear. Now, if you're just standing out here in the air, it might not feel like anything's pushing against you, but actually, air is putting pressure on you from every direction. You just don't notice it because it's the same amount of pressure in every direction. So if you push both ways like this, and there's the same amount of pressure from the right and the left, I'm not going to move. Right? I'm going to stay right where I am, and I'm probably not going to feel like there's any pressure at all. If there's only pressure on my left side, I'm going to get pushed this way, and if there's only pressure on my right side, I'm going to get pushed this way. The same thing happens with the balloons. When the balloons are just hanging, there's the same amount of pressure on both sides, and so the balloon is going to hang exactly where it is, unless, of course, there's a breeze. So what does Bernoulli's principle say? Bernoulli's principle says that if air is moving, it makes less pressure than air that's standing still. So, if on one side of me there's air that's standing still, we're going to use this arrow, and on the other side there's air that's moving, we're going to use this smaller arrow to show less pressure. I'm going to move this way because there's more pressure on this side. So air that's moving pushes less on the balloon than air that's standing still. It kind of sounds like it should be the other way around, but Bernoulli's principle shows us what really happens. So if you take your balloon and you blow in between it, remember there's still the big arrow of pressure on this side. All of a sudden, there's less pressure on the inside of the balloons, and that's going to push them this way towards each other. So air pressure applies to airplanes too. If an airplane's flying in the sky, there's going to be air pressure that's on all sides. And that means that it should stay pretty much where it is. However, airplanes are really heavy and gravity's acting on them really hard. And gravity is going to push them down. So, if you're building an airplane, you can't get rid of gravity. But what you can do is try to put something else that will push your airplane up so that it won't fall as much. This means that you won't have to use as much fuel getting it into the air, which is really going to help make your airplane work better. So let's use this as an imaginary airplane. The reason that I'm using this is that this is actually the shape of the side of an airplane wing. An airplane wing isn't perfectly flat. It's shaped like this, where at the front it's a little bit rounder, and at the back it's almost a point. It's very rounded on the top and almost perfectly flat on the bottom. This is actually also the same shape of a bird wing if you were to look at it from the side. So the reason this works is that this shape makes air go faster over the top of the wing and slower underneath it. So again, if you've got slow air on the bottom, air that's barely moving at all, that's going to push a lot of pressure. And if you have air that's moving really fast on the top, that's going to only push a little bit of pressure. If you have more pressure on the bottom than on the top, that airplane is going to go up. This shape basically acts as a slide for the air. As the airplane moves this way, the air that's on top is going to very quickly slide down the back of the wing, moving really fast. While the air on the bottom isn't really going to get touched at all by the wing, right? So it's going to stay pretty much where it is. This is actually a very similar shape to what a bird wing would look like if you looked at it from the side. And that's not a coincidence. Most modern airplane wings are actually designed to look like bird wings, because bird wings work at keeping birds in the air even when gravity's working against them. So you can thank birds and Bernoulli's Principle for why airplanes are designed the way they are, and you can use Bernoulli's Principle to trick some of your friends and family with our balloon experiment. Hope you enjoyed this magic trick and its scientific explanation, and I'll see you later. Bye!